All right, so still with geometry, I'm sorry, still with coordinate plane, but we are throwing in some geometry this time. So what I mean by that is we're taking it back to like finding the area of rectangles and triangles and trapezoids and all, all that good stuff. Sorry, it's like it's like the third video I've coughed in. All right, so the best way to do this lesson is definitely looking at some examples of questions. So I've printed them off and I've linked the handout that I'm using. So if you can print it off, you're welcome to follow along with me. If you can't print them off, then please just watch the video and make sure you understand how I'm doing these questions. There's only 10 of them. I'm hoping we can get through all of them, but let's just go ahead and see. All right. First question, let me zoom out some. Samuel applied the following 3 points on a coordinate grid as shown below. If Samuel is trying to make a parallelogram, what are the coordinates of the fourth point needed to complete the parallelogram? So one thing we need to remember here is what in the world was a parallelogram? Okay, we have to remember what that was. So remember, a parallelogram is kind of like a tilted rectangle. Okay, so the left and right sides match, the top and bottom match, they're congruent, and then all four sides are parallel to their match. Okay, so the easiest way to do this one is we're going to plot all 4 points that they've given us and see which one actually makes sense. I know it's kind of hard to see on the video, but these aren't just spaces. These are negative signs in front of these numbers. Um, I'm going to attempt to use different colors. I don't know how well you can see on the video, but hopefully you can see a little bit. All right, so the first one they give us is -6, -3. So right here. Okay. And to me, that's looking like a pretty good candidate right now. Okay, it kind of completes my parallelogram. So I'm gonna put a check next to this one because it's looking pretty good. Let's try another one. Let me use a different color. Hopefully you can see. So -4, -3. Okay, so that's my point now. So ignore this one. That's definitely not a parallelogram. Okay, because if you complete these lines, obviously this side is straight, this side is slanted. Those are not going to be parallel to each other. They're eventually going to meet up. So this one would definitely be a no. Okay, let's try another one. +3, +6. I hope you immediately rule out this choice because remember, now these two are gone. And last time I checked, this right here was definitely not a parallelogram. If we connected these lines together, that's not a parallelogram. So no to this one. All right, and then the last one is +6, +3. All right, and once again, last time I checked, straight line, this is not a parallelogram. So the only one that actually works was that very first one that I did, which was this right here. So that's your parallelogram, okay? I could have drawn in the lines for the other points that I did, but I didn't want the lines to get too messy. So now that we know which one it is, I will draw it in. So yes, this is the right answer. Okay, next one. Okay, the coordinates for 3 of the vertices of rectangle LM and P are given below. Okay, so vertices are just the corners. Okay, so they've given us 3 corners and we're missing that fourth one. They want us to figure out what does that fourth point have to be. Okay, so let's plot this. So it gives us 2, 4, and 4, 2, -1, -3. Okay, so let's kind of draw this in for what we have so far. All right, so you can kind of get an idea. Yes, it's a tilted rectangle, but you can kind of turn your paper if you need to see it. But you can kind of see that your last point needs to be somewhere in this area. Okay, obviously if it needs to form a rectangle, it needs to be somewhere over here. So let's see what points they've given us. The first one they gave us is 3, 1. 3, 1 is going to put you right there. That's obviously not the fourth point of my rectangle, so that can't be right. Okay. The next one says -2, -4. So -2, -4. That's down here. That's obviously not going to complete my rectangle either. So no. Okay, the next one, -3, +1. Okay, it's in the right area. Might not be exactly right, so I'm just going to leave that. I'm not going to put an X next to it yet because maybe it is the right answer. All right, and then the last one is -3, -1. Right, that to me is looking a little better because if we draw this in, that is definitely a rectangle. So this one would have to be D because that's the only one that makes it complete. Okay, next one. Which list of ordered pairs would form a parallelogram when connected by line segments? So this one, they give us all 4 points. We just need to figure out which one's going to make a parallelogram. So this one might get messy, so I apologize ahead of time. All right, so 8, 2, 5, -1, 0, 0, and 8, 2. So back to where we started. So this would definitely not be a parallelogram. And I hope you can see why. Because it obviously forms a triangle. So that is not a parallelogram. All right, let's do a different color so you can see. Next one, B. 3, 2, 5, -2, -3, -2. So -3, -2, and then -1, +2. Okay. So I can definitely see why this one might trick some people if you don't remember the names of your shapes. This shape that we just made in yellow is a trapezoid, so it is not a parallelogram, okay? But if you didn't remember that it was a trapezoid, you might be confused and think it's a parallelogram, so I can see why that one might get confusing. C, -2, what color have I not used? So let's use this one. -2, +2, -5, -2, -4, -5, and -1, -1. All right. This right here is definitely a parallelogram. If I turn it this way, you can see it a little better, but that is definitely a parallelogram. So C is going to be your right answer. If you wanted to plot D to see what shape that formed, to give you a better understanding, you could definitely do that, but for the sake of time, I'm going to keep going. Okay? Margot plotted the points, all these points right here on a coordinate grid. She connected the points with line segments. Which of the following best shows the shape of the figure Margot drew? Okay, so once again, for the sake of time, I'm not going to do this one step by step with you. All you'd have to do is plot all 4 of these points, connect them, and then it'll show you which shape that you've made. Okay, so you'd have to draw that one out and connect them to see what's going to give you. All right. Next one, quadrilateral QRST is an isosceles trapezoid. The coordinates for the 3 of the vertices are given below. Which of these points could be the last point? Okay, we haven't talked about this word very much, but isosceles means that 2 of the sides are identical. They're congruent, okay? So let's do this one real quick. We're missing that 4th point. So -3, -2, 3, 2, and 5, -2. All right, so here's the first 3 points of my trapezoid. All right, let's see where that 4th one's going to be. Obviously somewhere in this area right here. All right, so -3, +2 is the first one. Not looking real good because then my sides wouldn't be congruent. It says it has to be congruent, so maybe not that one. -1, +2. That one's looking a little better because when you draw it in, you can tell that now all these two sides are the same, okay? If I'd done this one, it still would have been a trapezoid, but it would have not been an isosceles trapezoid. Isosceles tells you that these sides have to be the same, okay? So that's why it has to be B. All right, next one. What is the length of line segment KN? All right, so this is just a distance question pretty much. They're asking you how far is it from K to N. All right, you can count your squares. 1, 2, 3, 4, 5. Or you could have thought about K is at 4, N is at 9. What's the distance between those two? And either way, you would still get 5. All right. If the figure below was graphed on a coordinate plane with both axes labeled in units, its vertices would be located at the 4 points given. In other words, they're saying, imagine this is on a coordinate plane. Based on the ordered pairs, which whole number is the length of the base of the figure? So remember, the base is the bottom. Once again, this is just a distance question. Remember, they're going to give you two numbers that are the same, okay? So I don't need these 6s, okay? They're both positive, so they're in the same quadrant. If they're in the same quadrant, you subtract. So all I'm going to do is I'm going to take absolute value of 8 minus absolute value of 1, and that's going to give me 7, okay? The top base would have been the same thing, because remember, it's a parallelogram, so they're congruent. Remember, we're not doing these because remember, they're always going to give you a number that's the same. And if you're looking at these numbers over here, nothing is the same. So you're not using those points. Okay. 7 right here. Page 7, question 8. If triangle PQR has a height of 4 units, what is the coordinates of point P? Okay. So in other words, they're just asking you, what is this coordinate right here going to be? And obviously, you can tell labeled by the coordinate plane that it would have to be, well, if you're going up, it's kind of confusing because it has it labeled at 6, 3, 6, okay? Oh, I'm sorry, I was looking at it wrong. Sorry. So yeah, we're looking for point P right here. So what's that point going to be? I'm going over 3 and I'm going up to 6. So that would have to be 3, 6 right there. Okay. All right, 2 more. Look at the coordinate grid below. What coordinates for point C would make ABDC a rectangle? So once again, we're just finishing off this rectangle. Here are the lines so far. You can kind of just draw it in yourself because this one's nice and big. So that would complete your rectangle. So in other words, what point is this right here? And you can tell that it is -4, -1, which is B right here. Very good. All right, last one. Rectangle ABCD has vertices -1, 1, 2, 1, blah, blah, blah. Sorry, I'm not reading all that. What is the perimeter of rectangle ABCD? So this is one that you do definitely have to plot it. And if you have room on a previous coordinate plane, you are welcome to use it. So for example, I'm going to go back to this coordinate plane right here. And we're just going to use this one. I hope that's not too confusing, but rather than spending time drawing my own coordinate plane, I'm going to use one they've already given us. So once again, I'm looking at question 10, but I'm plotting it on this grid right here because I don't think there's another one that's emptier than this. Well, maybe this one. Sorry to confuse you. So once again, I'm plotting number 10. So -1, 1. Hope this isn't too confusing for you. 2, 1. 2, -5. And then -1, -5. So I'm going to color this in real quick so you can see it better. So in other words, they're asking me, what is the perimeter of this rectangle right here? Remember, perimeter is when you find the length of every side and then add them up. I'm going to run out of time. This one right here is 3, 1, 2, 3, 4, 5, 6. This is 6. So 3 and 3 is 6. 6 and 6 is 12. That's going to add those together to get your final answer. I'm so sorry it's rushed.